Imagine stumbling upon a source of water that has been sealed away for an astonishing 2.6 billion years. This is exactly what geologists encountered in 2016, when they made a groundbreaking discovery deep within a Canadian mine. The revelation, which was documented in the prestigious journal Nature, has opened up new avenues of understanding regarding ancient microbial life and the remarkable ability of water to exist in isolation from sunlight for such an extensive duration. Even more fascinating is the fact that this ancient water continues to bubble up from the depths of the mine, and the taste of it left the research team quite surprised. This finding not only enhances our knowledge of microbial life on Earth, but also raises intriguing questions about the potential for similar life forms existing on other planets or moons in our solar system. Unveiling the oldest water on Earth. When the team of geologists, spearheaded by Professor Barbara Sherwood Lollar, first discovered this ancient water, they were taken aback by the magnitude of their find. Located nearly 3 kilometers beneath the Earth's surface, they encountered a flowing body of water that had been trapped in rock for over 2.6 billion years. Contrary to what many might assume, that it was merely a small pocket of water, the reality was that this water was actively flowing, and in much larger quantities than anyone had anticipated. When people think about this water, they assume it must be some tiny amount of water trapped within the rock, Sherwood Lollar shared with BBC News. But in fact, it's very much bubbling right up out at you. These things are flowing at rates of liters per minute. The volume of the water is much larger than anyone anticipated. This astonishing discovery prompted the researchers to ponder significant questions about how water could remain sealed for such an extended period while still harboring the potential for microbial life. The implications of this finding extend beyond our planet, suggesting that ancient water sources might also exist on other celestial bodies within our solar system. The significance of microbial life in ancient water. As the team delved deeper into their study of the water, they uncovered compelling evidence indicating that life had once thrived in this isolated environment. They found traces of sulfate in the water that bore the unique fingerprints of microbial life. These microorganisms had managed to survive without sunlight, relying instead on radiation emitted from the surrounding rock to generate the nutrients necessary for their existence. Sherwood Lollar elaborated on this remarkable finding, stating, "By examining the sulfate in the water, we were able to identify a fingerprint that indicates the presence of life. Importantly, this signal we observe in the fluids must have been produced by microbiology over an extensive timescale. The microbes responsible for this signature could not have done it overnight. It suggests that organisms have been present in these fluids for geological epochs. This microbial signature not only sheds light on the resilience of life, but also serves as a potential link to the existence of life on other planets. The long-term survival of these microorganisms implies that life could endure under similar conditions elsewhere in the universe, even in environments devoid of sunlight, but rich in chemical interactions." A deeper dive into the chemistry of ancient water. The chemical makeup of this ancient water further bolsters the theory that microbial life flourished in the absence of sunlight. The sulfate present in this water, unlike that found in modern surface waters, was generated through a reaction between the water and the surrounding rock. This natural process could continue indefinitely as long as the water and rock remain in contact, potentially for billions of years. The sulfate in this ancient water is not modern sulfate from surface water flowing down. What we've discovered is that the sulfate, like the hydrogen, is actually produced in place by a reaction between the water and rock, explained Long Lee, an assistant professor in the University of Alberta's Department of Earth and Atmospheric Sciences. This means that the reaction can occur naturally and persist for as long as the water and rock are in contact. potentially for billions of years. This extraordinary discovery reveals a dynamic, self-sustaining ecosystem where life could thrive for eons, driven by chemical processes rather than sunlight. The implications of this finding are profound, not only for understanding Earth's deep biosphere, but also for future explorations of exoplanets and moons in our solar system. What does 2.6 billion-year-old water taste like? While the scientific ramifications of this discovery are awe-inspiring, a more personal and somewhat whimsical question has captured the curiosity of many. What does water that is 2.6 billion years old actually taste like? For Sherwood Lollar, the answer came when she decided to taste the water directly from her finger. As a geologist who often samples rocks in the field, she was eager to see if the water's salinity could provide clues about its age. Upon tasting it, she found that the ancient water was very salty and bitter, and notably saltier than seawater, exactly what she had anticipated. This high salinity indicated that the water had been in contact with minerals for an exceptionally long time, further confirming its age. This light-hearted anecdote adds a human touch to the otherwise scientific exploration, showcasing the curiosity and excitement of the team as they ventured into uncharted territory in their quest for knowledge. So, what do you think? Could this ancient water hold the key to understanding life beyond Earth? Or do you believe that life as we know it is unique to our planet? Share your thoughts in the comments below.